In this video, we are going to talk about the combination circuit. Now, what is a combination circuit? It is a mix of both series and parallel circuits. So, in order to solve this, we need to first understand if the connection is in series, how do you get the total value of the resistance? And if the connection is in parallel, how do you get the total value of the resistance? And once you get to know those equations, then you can apply both side by side to get the final answer. So over here, as you can see, resistor R2 and R3, they both are in parallel and they both are connected in series with R1 and R4. Now, in order to understand why they are in parallel or why they are in series, we can take a look at the connections in a separate video. For now, since we understood R2 and R3, they are in parallel and they are in series with R1 and R4. So let's try to solve these together. Now, it's always the best idea to go with the connection first, which is against the battery. So as you can see, the battery is on the left hand side of the circuit. So we are going to get started with this section first, and then we'll try to go from right to left. All right. So in order to solve R2 and R3 first, naturally they are in parallel with one another. So we need to understand the equation for the parallel circuit first. So the final value of the resistance, which is R, can be obtained using this equation. 1 over R is equal to 1 over R2 plus 1 over R3. Again, that will give you the final answer to 1 over R. So you need to flip your answer at the end. You need to inverse the final value, and that will bring you to the correct value of R. All right. So this equation is specifically for parallel connections. And just as we are discussing about the parallel connection equation, we can even talk about the series connection equation, which is nothing but R is equal to R1 plus Rx. Now, why are we considering Rx? Because we don't know the value of the new resistance, which is going to get created over here at the end of R2 and R3, right? So Rx will be our new resistance over here, and that will get connected with R1 and R4. So in order to even extend this equation, we can even take R4 in the series connection here, right? So your value of final resistance, which is the final value of R, will become R1 plus R4 plus whatever the value we are going to get for Rx, right? Again, this is just an high level overview. Let's go step by step on all these equations as well as on these connections, right? So if you have a question, why are we not considering R1 with R4 first before we take R2 and R3 in the connection? The reason being, it's always a best idea to get the parallel connections resolved first, and then you can add all the series connections, at the end, right? So let's go with R2 and R3 first. Now that we already have understood the equation, which is 1 over R2 plus 1 over R3, so you can apply the values here, 1 over 30 plus 1 over 50. And if you do the math here, so you can simply use 1 over X feature in your calculator. If you are using one of those features, that's always going to be helpful. If not, you can always do 1 over 30 manually as well. So if you do 1 over 30 plus if you do 1 over 50, and that will bring you to an answer 0.053. You can do it in your calculator side by side just to confirm. Again, that is the value of 1 over r. That is not our final value, right? So in order to get the final value, you still need to flip it. You still need to apply 1 over x to your answer, and that will bring you to a value of 18.75 ohms. Again, ohms is the unit for the resistance, right? So 18.75, that is what the answer to a new resistance over here, that is what you are getting, right? So very simply, you can just draw a line over here just so that you can ignore the final part of the circuit, right? So you don't need to take a look at the right hand side of the circuit anymore now, right? You don't need to look for the 30 or 50 because your circuit has, you know, turned itself into a three resistor circuit, which is R1 plus R4 plus Rx, right? And the value of Rx is nothing but 18.75 based on what we have calculated using R2 and R3. Now the game is very simple because R1, Rx, and R4, they're all in series. We know the game for the series equation, which is R1 plus Rx plus R4. Since they are in series, so you can apply a simple equation for series connection. And in that case, you can just add all three values together. So 20 plus 20 plus 18.75. So if you do that, the final answer will become 58.75 ohms, right? So in this case, your final answer is nothing but 58.75. That's the total resistance value for this entire circuit, right? So this is how you solve a combination circuit. We can talk about more of these examples, but I think it's a good example to get started. And you can try one with some different values as well, and we can check the answer at the end.